I know we had done questions like this. You might have even had a 2Q problem in Chem 1. I know you certainly never had a 5Q problem in Chem 1. So these are questions, all these phase change problems are from chapter 10 in the book. You've been assigned a few questions from chapter 10. This would be similar to some of the other ones. Lisa? Yes, you would be given all the boiling and freezing point. You'd be given the specific heat of all the phases all day, yeah, if it's not water. Yep. But you'll see the water is in almost all of them. If I could, we're almost done. Just want to show you what some of the problems look like in chapter 10. Number 100, we'll look at first. Okay, in 100, it says, consider a 75-gram sample of water as a gas. Notice the physical state? It's not liquid water. It's at 125 degrees Celsius. What phase or phases are present when 215 kilojoules of energy is removed from the sample? So we're going to take out 215 kilojoules. We know, the question is what phases, what physical states are present. First, we have gas. The water starts as steam, so we've got water in the gas phase. Then we're going to cool it down. What you're going to have to calculate at number 100 is how much energy is required to cool it from 125 down to 100. Is there enough energy that's taken out to be able to condense that whole sample? So you're going to have to use the heat of vaporization, but put a negative sign in front of it because you're actually cooling it off. So it's negative the heat of vaporization, see how much energy it takes to condense it. And does it take all 215 kilojoules just to condense the water? If you still have more energy, then see how much energy it takes to get the water down to its freezing point. If you've run out of energy, then you just have gas and liquid present. But if you still have more energy that you can take out, then you're going to see how much energy it takes to melt it. Not to melt it, but to freeze it. And see if a solid is present too. So that's what you have to do on that one. But you're just going to keep seeing for every step on that graph how much energy does that take. Yeah, Lisa. Yeah, I don't have them on there now, but I will. Yep. Number 102, I think, is also one of the problems from chapter 10 that we have to do. Yeah, take a look at 102 in the middle. It's that chunk of sodium. A really small chunk of sodium metal is cautiously dropped into a mixture of 50 grams of water and 50 grams of ice, both of which are at 0 degrees. So the mixture looks like this. The sodium is going to react with the liquid water that's in there and do this. And it's an exothermic reaction. So the sodium, as it's put in here, is going to give off heat. And that heat is going to be used to do what? What's that heat going to be used for in this problem? What's that, Ari? Well, no, not so much. The products are going to be made, and in addition to the products being made, heat's going to be given off. So take a look at this. Look right here. What is the sodium being put into? What's that heat that's given off going to be used for? For what? Yes. What phase change? Keep going. See that ice? What is that ice going to do? It's an exothermic reaction happening in this mixture of water and ice. So heat's going to be given off to what? It'll melt the ice. You were saying the other way around. Yeah, we got ice there, and the heat that is given off by this reaction is going to melt the ice. Yeah. So that delta H value, the negative 368 kilojoules, that implies that that's how much heat is given off when 2 moles of sodium react. Are 2 moles of sodium actually reacting in this reaction? No, not even close. It's less than 1 gram. So what we're going to have to do is a little stoichiometry. We're going to have to take the mass of the sodium and change it into moles, and then we have this conversion factor. 368 kilojoules is given off for every 2 moles of sodium that reacts. So we'll have to scale it down and get the amount of energy that's given off by this chunk of sodium. Yes, Jacob?
Can you go back up to 100?
Yeah. Go ahead.
So what would happen if you didn't have enough energy to go all the way through the phase change?
Even partway through the phase change, you're making some liquid.
Right.
So yeah, you'd say that there's gas and liquid.
Oh,
Present. Yeah. Even if it doesn't go all the way through the phase change. Yeah, that's good. Anything else about these? Just a couple that are assigned. I want to give you a little clue as to how to get started on those. All right. Just very quickly, a very quick rundown of the lab that we're going to do. You're going to run 2 experiments. You're going to find the delta H of a reaction between magnesium and HCl. That's a single replacement reaction. This is no big surprise, but in fact I don't even give you what the products are because that makes it just too easy. You figure out what the products are, you'll have no trouble with that. And then what is the delta H of that? Then you're going to do the same thing, and this is going to be in a coffee cup calorimeter. We have those already set out. And you know, we are kind of taking a risk here, putting this expensive equipment out in the room the day before we're actually going to use it. We're keeping an eye on it, though. We'll probably watch out for security cameras or whatever. Do not steal those things. It's a budget buster. We have these high-tech lids, so you're going to love these lids. Check this out. I mean, we do not want any heat loss to the environment. Look at Mr. Hubbard, they're laughing. Because the 2 of us always laugh about this equipment, too. It's the cheapest lab we'll do all year. What's that? I know. Welcome to the world of high-tech science. So yeah, the lid is so high-tech it even has a hole for your thermometer to go through. Isn't that nice? Look at that. So, yeah. Wow. We don't have to remove the lid even. I mean, people think of everything these days. So anyway, yeah, you're going to, of course, you need the amount of heat that is generated in this reaction. So we're going to have to measure the mass of the water that we put in there first. The specific heat of water we're going to know. And we'll need the delta T. So make sure that you get the initial temperature of the water before you run the reaction. And then, in fact, you know, Mr. Hummel, I was talking to Mrs. Robles, too. We use those wireless. I do because I think that it's easier to see when the... So, yeah. You guys probably used those last year. You have one. Yeah. We'll have to download an app to our phone, unless you did already last year, but you still have to get my new phone. It's a real simple deal. So you don't have to use it. Not yet. We'll dig our heels in on that.
No, just go in front of us.
We do use, because we can afford it, we use 2 cups, one nested inside of the other. Your station's going to have 2 cups in it. That's on purpose. I know. Please be very careful if you drop this and break both cups at the same time. I mean, just be very careful with these. Sometimes, by the way, these cups, one of them will have a hole in them. Make sure that the one has a hole in it. It's the outside one. You don't want the water leaking into the other one. You do want to contain all the water in one cup. There's one thing I would at least caution you about. If you get done with the first trial and you see that there's water in the second cup, you probably have sprung a leak in the first one. Just switch them, unless the second one has a hole too. Okay? Yeah. So yeah, you're going to run 2 reactions involving magnesium. Well, one is magnesium with HCl, one's magnesium oxide with HCl. And then you're going to wind up actually using Hess's law to generate, my question is going to be, what is the heat of formation of MgO? So you should be able to write a chemical equation that describes the heat of formation of MgO, and then manipulate your equations in the lab that you use. You're going to measure the delta H, so you should be able to come up with a Hess's law situation where you have equations, with their delta H's, and you have a target equation, the heat of formation of NGO, and you'll try to find it. That's going to be a lab write-up. We'll talk more about that before you do the lab on Monday. The lab is going to be due on Wednesday. Hope you have a real nice weekend. Get together with somebody and do the problems in the chapter this weekend. Carve out some time. Work with somebody else on these. Some of them are hard.